guys, it's Mary and welcome back to Study Journey. I'm back with another problem of the week, AMC 10 problem, and this one is about prime numbers, so like using prime numbers and equations, and I will be explaining this problem in this video, so without further ado, let's get on with the video. This is AMC 10B problem 15 of the year 2002. The positive a, b, a minus b, and a plus b are all prime numbers. The sum of these four numbers is even, divisible by 3, divisible by 5, divisible by 7, or prime. Here our keywords are positive integers, prime, and the sum. So keep these in mind as we are solving. So we know that these four numbers are all prime numbers, and the only way a number is prime is that if it is only divisible by 1 in itself. So 2 is the only even prime number, because any other even number is divisible by 2. Remember that two evens added together, an even number plus an even number is even, and an odd number plus an odd number is even. So the only way for two numbers to be added together to be odd is that if it is an odd number plus an even number. So we know that if both of these are prime, then one of these has to be an even number, or else these would be both even and then they won't be prime. So which one is the 2? Because 2 is the only even prime number. So we know that either a or b has to be prime. We know that either a or b has to be 2. Since all of these are positive integers, then if a equals 2, then a minus b has to be smaller than 0 because they're both prime, and 2 is the smallest prime number. So b is equal to 2. So now we can substitute and it would be a 2, a minus 2, and a plus 2. So let's take a closer look. The three numbers a minus 2, a, and a plus 2, one of these numbers has to be divisible by 3. Why? If you were to divide a number by 3, so let's let a equal 3n plus k, where k is the remainder when divided by 3. Then we can know that a minus 2 would equal 3n plus k, which is the a, and then minus 2. Same for a plus 2, that would be 3n plus k plus 2. Now what can k be? K can either equal 0, 1, 2, and that is it. Because the remainder, when divided by 3, it can only be 0 where it is divisible by 3, 1 where the remainder is 1, and 2 where the remainder is 2. If the remainder is 3, then it will go back to 0 because you can divide it by 3 and then there won't be any remainder. So let's substitute in k. If k were to be 0, then a would equal 3n plus k, which is 0, then it would just be 3n and a would be divisible by 3. If the remainder was to be 1, then this would be 3n plus k, which is 3n plus 1. A minus 2 would be 3n plus 1 minus 2. And then a plus 2 would be 3n plus 1 plus 2, which is 3n plus 3. And that is also divisible by 3. And if the remainder were to be 2, then this would be 3n plus 2, 3n plus 2 minus 2, or a minus 2, and that would just be 3n. So that is divisible by 3. So now we know that one of these numbers, a minus 2, a, or a plus 2, they have to be divisible by 3. Now, since all of these are prime numbers, and it has to be divisible by 3, then it can only be 3, because any other number that is divisible by 3 is not a prime number, because it would be divisible by 3. Which one can it be? If a was to be 3, a minus 2 would be 1, and that's not prime. And if a plus 2 is 3, then a would be 1, and then this would be a negative number. So only a minus 2 can equal 3. And then we can solve it out, a is equal to 5. Now that we know a is 5 and b is 2, we can just substitute it in for each. So it would be 5, 2, 5 minus 2, and 5 plus 2. So this set of number would be 5, 2, 3, and 7. And now it is asking you what the sum of these four numbers is, and we can just easily solve it out. 5 plus 7 is 10, 5 plus 2 is 7, and this will be 17. Now let's look at our answer choices. We know that 17 is not even, nor is it divisible by 3 or 5 or 7, and it is a prime number, so the answer is E, prime.